All right, good morning. How's everybody for Thursday? It's already Thursday. And yesterday was so nice. It's like 60 degrees or something like that outside yesterday, which is really nice. I think this weekend looks really nice too. So today we are going to continue talking about exponential functions. The first half of this chapter is on functions that increase rapidly. That's what an exponential function does. Or it could decrease rapidly, which is the decay function that we're going to look at today. So we split it up into two different sections, increasing one day, decreasing going down the next day, or decaying is what we call it for the actual function. We'll look at some applications of those. Whatever we don't finish today, tomorrow we'll wrap up. So tomorrow we'll go through a couple more application examples. We can look at a few more graphs, whatever we need to do tomorrow to kind of pull together the first two sections. And then on Monday of next week, we are going to discover, I think that's a good word, a new number in math that's similar to pi. So pi is called an irrational number. The symbol pi represents 3.14. So we're going to discover a new number on Monday that'll be a symbol that represents a number. And there's going to be a little activity that we'll go and kind of discover that, but it actually is part of the exponential function family. So before we get to the book homework, your tests have been graded, returned to you. Your chapter 6 packet has been graded and returned to you. All of that is in PowerSchool as of yesterday before 5 o'clock. So all of your grades are updated as of this point in PowerSchool. Everything on Google Classroom is updated as of this point in on Google Classroom. If you would like or are interested in taking a retest, and I apologize, this I'm pulling up from, this is obviously on my iPad, so it's not quite as neat as it is on my laptop. I didn't save it as a PDF yet. But if you're interested in doing a retest correction, there were two portions of the Chapter 6 test. You can choose to retest one portion because you didn't like the score you received on the first portion, or you didn't like the score you received on the second portion. Or you can choose to retest on both. It's totally your call. In order to complete the Chapter 6 retest, the first thing you have to do is make corrections to the problems that you missed. And I have my standard form where you write the problem number down. You repeat the original problem and then correct it. And then next to it, either from your book or from your homework or from one of the worksheets that we've done, you find a similar problem, and similar means almost identical. It should have the same power, just different numbers. The same square root, just different numbers. You would find a similar problem and practice that similar problem. So any problems that you got wrong, either on the first portion or the second portion, whichever portion you choose to do, you would make corrections and find a similar example. And then to do some extra practice, because the whole goal of doing test corrections and retaking a test is so that you are fully learning and understanding and comprehending the material. So depending on which portion you would like to do, I have different options of problems for you to complete as practice problems to prepare you to retake the test. So part 1 in the back of the book, page 1015, there's actually a whole bunch of practice problems all for chapter 6. So I have select problems if you want to redo part 1. If you want to redo part 2, again, I have select problems for part 2. So this is for the chapter 6 retest. And then the last part of this form I have is for you to circle. I would like to take part 1 over, part 2 over, or both parts of the chapter 6 retest. This will be posted to Google Classroom after class. I didn't get to post it. I'm going to blame it on Mrs. Everhart. She came over and bugged me. So I didn't get to post it yet, but it will be posted to Google Classroom with the same information given. This must be completed by next Wednesday, March 3rd. The retest must be done by Monday, March 8th. So you have a little less than a week to make test corrections and practice. And then you have about 10 days to get it all done and the test completed, the retest completed. Are there questions on any of that process? Ava?
If you score lower on the test retake than you did on the original one, do you take the test retake score?
I take the best score of the two.
Okay.
So I would not take just the retest, whichever one you perform best on. Okay. So if you ended up doing better on the original test than you do on the retake, I'm going to keep the original score.
Okay.
Other questions? So again, the option is yours. This is up to you. Do you want to complete the retest? You weren't happy with the score that you got on one of the portions. And the whole goal is for you to learn the material, because that is our goal, especially in math, because you need to move forward and you need to understand the material because we continue using it. I use this same process in honors, trig, and pre-calc as well. So I do the same process. Mrs. Everhart next door, she teaches AP Calc. She uses the same process in AP Calc. So we try and be consistent so that you move from one teacher to the next, and hopefully you have some consistency in your math education. Questions on that? If you do have questions, let me know. If you ever want to meet via Zoom, or everybody's here next week, feel free to ask questions as you're in homeroom. But I can always meet on Zoom as well to go over any questions that you have on the test. I can answer anything that you weren't sure of. I always try and make a lot of comments on the test so that you can kind of understand where the process was supposed to go. But if there's anything you don't understand, always let me know. So again, this will be posted to Google Classroom after class so that you have time to look at it as well. All right, so we are going to go to just 2 problems of the homework. So if you want to pull out your homework, I chose 35 because I wanted to kind of focus on the pieces of information that you were asked to find and make sure that you understand what it's asking for. And then I also chose 37 because that was the last problem that I gave you a formula to, and I want to make sure we can work through a problem together with all the information given. So looking at 35, our book is old. You can tell that we're talking about the dates 1997 to 2002. And none of you were born in 2002. So it's an old book. It still works because math is math is math, right? Math doesn't really change. So from 1997 to 2002, the number in millions of DVD players sold in the United States can be modeled by the equation. So this one's given to you. N equals 0.42, and then in parentheses, 2.47 to the T, where T is the number of years since 1997. Identify the initial amount, the growth factor, and then the annual percent increase. And I want to make sure you understand the difference between the growth factor and the annual percent increase. Part B says graph the equation. You were asked not to graph it in the directions on the homework assignment, but instead estimate the number of DVD players sold in 2001. So let's first identify the initial amount. Jaden, what is the initial amount? Yeah, so 0.42, that first number is our A, and that represents the initial amount. And that's in millions. So Jaden, if I wanted to find out what that number was, if I said 0.42 in millions, what could I do to get that actual number?
So
multiply it by a million. So I have 0.42, multiply that by a million, and then you get the actual number. Does anybody know what that actual number is if you take 0.42 times a million? Yeah. And then this is what, DVDs? Players, not just DVDs. All right, so that's the first value. The second thing is the growth factor. Where is the growth factor in the equation? Yeah, within the parentheses. So the value in the parentheses is the growth factor. And that is 2.47. So our equation for exponential growth is the initial amount plus or times 1 plus r to the t. This number is called the growth factor. 1 plus r. That is the growth factor. The last question says the annual percent increase. If the growth factor is 2.47, and that represents everything in that parentheses, then your annual percent increase or your rate, I could just set equal to 1 plus r. And Gabby, that percent increase would be 1.47. But if I write that as a percentage, what would you get? 147%. Questions on that? So I want to make sure everybody understands kind of what they're asking for. So the number in parentheses, the whole number is called the growth factor. But that number represents 1 plus r. 1 because you have 100%, r because that's the rate that you're increasing by. And it's given to you as a decimal. If they're asking for a percentage, you need to turn it into a percentage value. Questions? And then for part B, you would take the equation they give you at the top. And if you're finding the number in 2001, how many years is it from 2001? If I start in 1997? 4. So you would plug a 4 in for T. And then you just plug it in that equation, put it in your calculator, and solve. Questions? All right, looking at the second problem I wanted to go over. You deposit $2,200 in an account. Find the balance after 4 years for each of the situations below. And this is the formula that I gave you for interest. And we didn't really get to talk about it because we were out of time. So you deposit $2,200 into an account. Lacey, do you know what that $2,200 goes in for? It does go in for P. So the amount that you have, your initial amount, the amount that you're placing in an account, that is the P. It's called the principal, but that's your initial amount. So the initial amount's always going to be in front of parentheses, no matter what type of word problem it is. What you begin with goes in the front. And then inside, we have 1 plus. For part A, it says the account pays 3% annual interest. So the rate is 3% or 0.03. And then it says compounded quarterly. That's our N value. How many times a year would be quarterly? How many quarters are there in a year? Cody? 4. So the N is 4. So the number of compoundings, that means each time they compound your money, that's when you earn interest. So 4 times a year, you're getting a statement saying this is the money in your account. And that's just done 4 times a year. And then the exponent is N, which is the quarterly, and then T. And the time, it says, is also 4 years. So that's how you would plug in your information. For part B, you have the same information, the same amount, but it's 2.25%. So that would be 0.0225. And it says monthly. Well, there are 12 months in a year, so I would divide it by 12. And then I would have 12 times 4. So you can see the difference. The rate has changed. The number of times has changed. But the number of years is the same because we're talking about 4 years. And then last one, part C. Still the same amount. My rate is now 2%, so 0.02, but it's compounded daily. How many days are there in a year? 365 in a normal year. Last year was a leap year, so there was that extra year. And then I would have 365 times 4. Questions on that?
Miss Kame,
Yes.
for the first part, instead of putting 4 for N, I put 0.25 because it was like quarterly. Would I just have
So-
to put 4?
Yes, yes. So like how many times would that be done? I understand where you're getting the 0.25 to represent a quarter or a fourth. But yeah, how many times a year would you be getting money in your account? And it's 4 times per year. So N represents the number of times. Other questions?
Did you go over number 12?
Over number 12, is that a graphing problem?
Yeah.
We're gonna do more graphs today, so I'm gonna say no.
All right.
Because the process is the same, the graph just is gonna go down and go instead of going up. And I wanna make sure that we do practice more graphs, so if you need to, stay after class and I can look at it with you. So in your packet, if you want to turn to page 7, we are gonna do more graphing today, and the process is going to be the same. Our graphs are just gonna go down instead of going up, but we're gonna find the values for the functions the same exact way. So page 7, we're graphing and using exponential decay instead of exponential growth. Our equation is still exactly the same. A, B to the X. The B value is between 0 and 1. It's a fraction that's less than 1. That makes it decay instead of grow. So if the number is bigger than 1, it grows. If it's between 0 and 1, it decays, it decreases. The decay factor is the B value. So that B value can be the growth factor if it's bigger than 1. It can be the decay factor if it's between 0 and 1. So it represents both cases. It just depends on the number that you're given, whether it grows or decays. The parent function we looked at yesterday for the exponential growth function was exactly the same picture, except that it increased. Now, this parent function for the decay is going to decrease. It still has that same line. Yesterday, we called that line the asymptote at the x-axis. That line is still there. The graph will kind of flatten out, just kind of skim eventually. It looks like it's horizontal. It does continue to slightly decrease, but it skims along the x-axis. So, Gabby Snyder, I think I asked you this question yesterday. What is the domain of this graph if it continues left and right? Yeah. And then Gabby, if it goes to this asymptote thing, this horizontal line, and it doesn't touch it, what would the range be? So if we're on the x-axis, what's that y value when you're at the x-axis? 0. And how high does it go? To infinity. Remember that 0 gets a parenthesis. That parenthesis means it never touches it, but it'll get really, really, really close to that value. So we're going to look at graphing a decay function. Notice the equation looks exactly the same as the ones you graphed yesterday. So we have y equals 2 to the 1, 2, and then 1/4 to the x power. 2 times 1/4 to the power of x. We're going to graph this decay function. How do I know it decays? Why is it a decay function? Jaden?
Because 1/4 is between 0 and 1.
Because 1/4 is between 0 and 1. So that B value, whatever's in the parentheses, that's what makes it grow or decay. So this is going to go down because it's 1/4. If it was 4, it should go up. So make yourself a little T-chart. Pick the same 5 numbers. And we're going to plug them in. So let's talk about this. What happens when you have 1/4 to the -2? So what happens if you have a fraction that's already a fraction form and you're raising it to a negative exponent? What do you think happens with that fraction?
Would it flip and then
Yeah.
our number would still be the square?
Exactly. So that number is going to flip. That's what a negative exponent does. So if it was 4 to the -2, it becomes 1/4 squared. Well, it is 1/4 to the -2. So it flips and it becomes 4 squared. That's what a negative exponent does. It flips your fraction. 4 squared is 16 times 2 is 32. So a negative exponent flips your fraction. The next one, we have 2 and then 1/4 to the -1, which is really 2 times 4. 2, 1/4 to the 0, 2, 1/4 to the 1, and then 1/4 squared. So a negative exponent flips your number. If it's a whole number, it becomes a fraction. If it's a fraction, it becomes a whole number. Just the opposite. So my second value, 2 times 4 is 8. My third value, 1/4 to the 0 is just 1. So that's 2 times 1. My value for the fourth value here, when x is 1, I have 2 times a fourth. Well, that's a half. And then I have 2 times 1/16 for my last number, which is 1/8. Don't give me a decimal. Keep it a fraction. Make sure it's reduced. Questions on getting those values? Use that wonderful brain. Expand that brain of yours. Now we're going to graph it. So notice that this time it starts up high. We're not going to graph 32. But at -1, we'll count up to 8, which is 1 extra spot. Just expand our graph a little bit there. At 0, we're at 2. And then you can see this time it decreases rapidly instead of growing rapidly. 1 is at a half, 2 is at an 1/8. That curve of the graph, where those points are getting closer together, that's where it starts flattening out. So connect your points, make it level off horizontally. Make sure you extend it beyond those points a little bit, and then draw in that horizontal line. Mine wasn't so horizontal there. There we go. That asymptote line. So Grace, what would the domain of our graph be? And that didn't change. So whether it grows or decays, I can choose any value for x. It's going to continue to stretch left and right. But the range, Grace, would be
0.
Yeah. That really didn't change either because it's still at that asymptote, that crazy word that looks funky, asymptote. Horizontal line, barrier. Think of it as a big wall that the graph can't cross through. Anybody watch WandaVision? I just watched the newest episode last night.
Did you see the end credits scene?
Yes, we stayed, yes. My younger daughter was like, Mom, I think there's more. Because we always turn it off because there's so many credits.
Yeah, there's like 7 minutes.
But that like red wall that they try and break through, you can't break through this wall. It's an asymptote. Can't go through that one. We like WandaVision. My daughter is a big Avengers fan, the older one.
My mom doesn't understand it whatsoever. Every 5 minutes.
Well, I don't either because I must be exactly like your mom. We'll probably be friends. because I don't watch any of those Avenger movies, but then I thought, well, this looks like a great family show. I should watch it. And I don't understand anything. Yeah. I'm like, who's this? Who's that? The Halloween episode. I'm like, who's she? And like, she's like, Mom, that's Wanda. I'm like, who? Like Wanda in the costume. That's what she looks like in the comics. So I was like, oh, okay. I should be a better mom some days. I should probably watch all those movies with her. Maybe someday. I'll put that on my someday list. All right, questions with graphing that function. We're gonna skip B. We're gonna go down and see if we can graph the next two that have those shifts. So how does it shift left? How does it shift right? We're gonna graph it the same exact way. We have y equals 2. This one's a little tricky because it's 3/5. We're gonna have to use a bit of brain power there. And then the x minus 1 plus 1. We're ignoring that shift right now. So we're gonna graph the 2, just the 3/5 to the x. So remember, you're graphing the initial amount, the decay or the growth factor to the power of x. Ignore the minus 1 and the plus 1. This one's a little trickier. Come on, there we go. Might need to have a little bit of scratch work on the side, a little bit of mental math here. So we are taking 2 3/5 to the negative 2. And Jaden, I'm going to come back to you. What do you think the negative exponent does to the 3/5? So it becomes 5/3. So that's 2. And then 5/3 is squared. Remember properties of exponents. Square the top, square the bottom. So 25/9. You're taking 2 times 25. That 2 is really like 2/1. So 2 times 25 is 50. And then I have 59ths. And I know you're saying, oh, Mrs. Can I just plug it in the calculator and give you a decimal? That's cheating. Come on, make that brain work. The next one, we have 2 3/5 to the negative 1, which is really 2 times 5/3, which is 10/3. 2 times 5 is 10 divided by 3. Plugging in the 0, that one's nice, because any exponent to the 0 power is always 1. So that's nice because 2 times 1 is just 2. That's always going to be that first value there. That's your initial value. And then 2 times 3/5 to the first is 6/5. 2 times 3/5 squared is 2 times 9 25ths. Which is 18/25. All right, so if I have 50/9, I know 45 divided by 9 is 5. So 50 divided by 9 is going to be a little more than 5. So at -2, we're going a little more than 5. We can go in between there. 10/3. Well, 9 divided by 3 is 3. So 10/3 must be a little more. Actually, 3 1/3. At 0, we have 2. 6/5 is a little more than. What is 6/5? A little more than 1. And then 9/25 is less than a half. Place it there. So make your graph, continue it horizontally. Ooh, that wasn't supposed to make a line. There we go. So that's my graph.
I might just be crazy, but is it 1825?
1825. Oh yeah, I was looking
Okay,
at this
sorry,
one
I
here.
don't-
No, it's my fault. I was looking over here. 1825 is about a little more than a half. My fault. No.
No, I'm sorry. I didn't
No,
mean to
no,
correct you.
not at all. I'm glad you did. I was looking at that number for some reason and not over there. I don't even know why. Yeah. Nope, you're fine. Now, the last thing we have to do is get this graph to shift. How do you move the graph? So Ava, do you know how this graph moves based off of the x minus 1 plus 1?
So H would equal 1 and H to the right one.
Good, nice. So we're going to move each of these points right 1 and up 1. So my first point is going to be off the graph. So right 1, up 1. Connect. Again, try and make it curve. And then level off horizontally. The K value is where that asymptote is located. So K is at 1. That means I have an asymptote at 1. That's where my graph should level off. Questions? So yes, I know that mental math, making you think a little bit. Let's see if we can do the domain and the range, and then we'll try that other graphing problem down below. Domain is always negative infinity to positive infinity, every single time. Alyssa, where does the range start at? So what's that horizontal line? My dashed horizontal line here, where's that at? 1. So it starts at 1 and it goes up. Remember, when you're looking at a graph, you're looking at the bottom point. How high up does it go? So even though this graph is going down, the range still starts at the lowest point and goes up. Questions? Why don't you try the next graph? So try B. Graph the original function. It has 2/3 in it. So we're graphing 3 and then 2/3. Anytime you plug in a 0, it's going to be that initial amount, the first number. Every time you plug a 0 in, it'll be the first number. Make sure you reduce. When you plug in a 1, you get 6/3, which is a nice number of 2. When you plug in a 2, you get 3 times 4/9, which is 12/9, or 4/3. So this graph, just be careful, it's scaled by 2's. So I'm going over to -2. 27/4 is a little more than 6. Oops, over to -2. 9/2 is 4.5. I have 0, 3, 1, 2, and then 2 4/3. Does anyone have questions on graphing the original? Eva, do you know how it's going to shift this time?
Okay, so it would go to the left, -1, down -3.
Nice.
I don't know, because it counts by 2.
Yeah, so it's a little tricky, right? It counts by 2s. So we're going over -1, which means you're just going halfway through the box. So halfway through the box, and then down 1 box is 2, down a little more would be 3. I know it's hard when it's counting by 2s. So you're going over half a box, down 1 box is 2, and then down like an extra half. Ugh. So it is tricky because it's counting by 2s here. When you're graphing that asymptote, look at your K value. It's -3. -3 is in between -2 and -4. That's where your graph should start curving toward. So the K value is the dashed horizontal line, the asymptote. That controls your range, which is -3 to infinity. So if you can remember, K and the range go together. Questions? So tomorrow we will do some application problems. You have 7 questions for homework tonight. Predominantly it's graphing problems. So there's 6 of them I think you're going to graph, and then there's 1 application problem that you'll look at. Please make sure when you graph, follow the steps, graph 2 functions, the original and then the shift of the graph. Tomorrow we'll wrap it up with doing a couple word problems, have some time in class, hopefully like the last 10 minutes or so, to practice through some word problem applications. Questions? You good?
Yeah, I think I was just confused, like, because there was like 4 thirds, and I didn't know how to do that.
Okay. The negative exponent.
Yeah.
So it flips, takes the reciprocal of it. Or flips it. Anybody at home have questions? So for those of you at home and remaining virtual, just a little info about next week. On Monday, we start at 7:20. So class has been starting at 7:25. I'm supposed to show announcements at 7:20 and I don't. So class will begin at 7:20. Announcements will happen at 8 o'clock. So if you're at home remaining virtual on Monday, please be here by 7:20 so we can start class at 7.